Hello, and in this video, we're going to look at how to use patterns to build molecules by looking at the different structures and how atoms combine to build molecules. In particular, we're going to focus on salts since that's been what we've examined in this lesson. So as atoms combine to fill the outer energy level, they create chemical bonds. And they do this by either gaining or losing electrons to become more stable. The way that they either gain or lose is in order to fill the valence electron level. And that magic number that they're trying to reach is 8 electrons. When the atoms reach 8 electrons and they have that full valence electron level, that gives them increased stability. So in order for them to get that stability, they create these bonds with other atoms by either gaining electrons to reach 8 or losing electrons to reach 8. As they gain or lose those electrons, they become bonded to each other because now they have those opposite charges. And as we've seen in earlier lessons in this unit, we know that opposite charges attract to each other. So we're going to use these different patterns and the numbers of electrons in the valence levels to help us predict what chemical formulas are going to be made when different salts combine. We see that cesium has 1 valence electron. And when we look at sulfur, we see that sulfur has 6 valence electrons. So we're going to use a table to help us determine if these are going to gain or lose electrons when they bond together to form a salt. So when we look at cesium, again, it has 1 valence electron. So in order for it to reach that happy number, that full shell of 8, it's going to need 7 more valence electrons. So here's where the tricky part comes in. In order to determine if it's going to gain or lose electrons, we think about what is it going to be easier to do? Is it easier to gain 7 electrons or easier to lose 1 electron? So it's a lot easier in terms of atoms and bonding for it to give up 1 electron or lose 1 electron than it is for it to gain 7. So it's going to lose 1 electron. So we know from the atom builder that atoms are neutral, meaning that they have equal numbers of positive protons and negative electrons. So in this case, since cesium, when it bonds with other elements, wants to lose 1 valence electron, now it has 1 less electron than it does protons. So this means that cesium is going to have a charge of +1 because it has 1 more positive electron than it does, or positive proton than it does the electrons. So in the case of sulfur, we see that sulfur has 6 valence electrons and it needs 2 more to reach 8. So is it easier to gain 2 or to lose 6? In this case, it's easier to gain 2 electrons. So as sulfur gains these 2 electrons, it has 2 more electrons than it has protons in the atom, which means it has extra negative charges. So that means that sulfur, as it bonds with different metals, is going to have a charge of -2. So let's look at what this looks like when they actually do bond. So we know that sulfur needs 2 electrons in order to become happy. So cesium only has 1 to give, but we need a second one. So that means we are going to need 2 atoms of cesium to bond to our 1 atom of sulfur. So in this instance, I've used different colors to indicate where the electrons are going from so that you're able to trace them back. So cesium, I've used black, and sulfur, I've used gray. So to indicate that cesium is giving up its electrons to sulfur, I've used these teal lines, okay? And I've shown them matching up with the electron on the sulfur that's alone. So electrons usually like to travel in pairs. So as we look at this when they're bonded, we'll see that both of our cesium now have a +1 charge. And now, since the valence electron it did give up, the energy level right below it is full. So both of our cesium atoms are happy. And then this instance now, our sulfur has a -2 charge. So in this case, these are both ions now. And we can see the extra 2 electrons that came from the cesium atoms. So while this is how they are living separately, since they've exchanged these electrons, now they're bonded to each other, and we indicate that with these lines. Okay, so each line indicates how many electrons have been given up. So 1 electron has been given up by each cesium atom. So each cesium has 1 bond with the sulfur. So when we go to write our chemical formula and determine our ratios, we see that we have 2 cesium atoms to every 1 sulfur. So as you write your chemical formulas, remember that in this instance, the metal, which is going to be found more towards the left-hand side of the periodic table, will go first. And the way I always remember that is because the metals are positive, we give the good news first and the bad news second, or the negative news second. So I'm going to have the symbol CS. And then to show that there's 2, I'm going to write the subscript 2 behind it. And then I want to write the symbol S for sulfur. Now, if we see there's only 1 sulfur atom here, so all I simply need to do is just write the symbol S for sulfur. And then when I'm naming this, we'll see that we call it cesium sulfide. So in this instance, the metal retains its name, so cesium, but the nonmetal that comes second, the ending is changed to IDE. So instead of cesium sulfur, we take the UR off and we add IDE, so sulfide. So if we were bonding cesium and oxygen together, it would be cesium oxide and not cesium oxygen. So as you continue on with working, we can see here on our periodic table showing our valence electrons, and notice that we're not showing the transition metals. We can see that we have the metals over to the left and the nonmetals over to the right. So again, remember those patterns of, is it easier to gain electrons or lose electrons, to determine if they're going to gain or lose when you're writing your example chemical formulas. I hope you found this video informative, and don't hesitate to ask if you have any questions.